Yes. Otherwise, you will see a lot of puppies around. Yeah.
Oh, okay. Isn't that good?
No, I mean no. Balance is good. Too much is not good. Too much of everything is not good. Okay, good. Like, back to this. So I think the iPad is kind of like castrated by the school, and then that's why your
By the school?
I don't know.
No, his one is the personal one.
Oh, personal one.
Yeah,
Okay,
it's
then
not like mine.
then is your brother is yeah. So your brother need to explore lah, on his own. Okay, next question.
Oh yeah, can we do the
Oh, done for this one already.
yeah, can we do the
You mean similarity,
yeah,
congruence?
congruence and similarity, yeah, both of them.
Yeah.
Which there's also one
which one? Which one you want to talk about? Congruence?
Yeah, can.
3, question 3.
Yeah.
Okay, good. Let's take a look at 3.
And also I want to look at one more thing.
Yeah, which one?
Is this one.
You just turn to me and then.
I think it's the one you're talking about.
Yeah, this is the one I'm talking about, exactly. So can you see AB, right? AB is where? AB is this one, right? Can you see the sign C, that one? Actually, I have talked about this area. I find the area.
Yeah, area of triangle is half AB sine.
Yeah. So in fact, you might not need to use that. But you can use mine. Okay. Okay. So tell me the letters. Where it is?
A. Yeah. Then B. C. Then that one is C.
Down is C.
No. The one you just.
Oh, okay. C.
Yeah, C. There's C. Then now is.
It's 12 o'clock.
B.
Angle is here, right?
Yeah.
Okay, good. So let me not use yours, but I can use yours.
Okay.
So which one you want to see as a base? Let's see here.
Okay.
So half times base times the height, right? So the height is here, right?
Correct.
So given this angle, so this is your opposite, right? Okay, good. Continue. So height, which is the opposite, is equal to, what do you have? You have this hypotenuse.
Yeah.
Which is the B, right?
B.
So
Yeah. B.
sine angle C is equal to opposite, which is our height, over the
B.
hypotenuse B, right?
Done.
So H is equal to sine angle C. So B, generally you put it in front now. Okay, so did I derive your, yeah, so I think I kind of like prove your this formula already.
Alright, that's quite simple.
Okay, so that's the way to get the area. You might not want to memorize this, you just do it on the spot. Okay, good. Yeah, do you have other questions from your list?
Let me go all the way to the bottom.
Okay.
Let's see. Intermediate. There's only one intermediate question.
If not, I will go through the congruence.
But you can look at it if you want.
Oh, if you look at this, you might as well look at the one I have here. Yeah, this one. Yeah, they got the north and bearing. Okay, good. So first thing first, bearing of L from M. How do you change this statement?
Bearing M naught.
From M.
From M naught.
North.
L.
Yeah. M north. There you see, they specify the north to you. From M north to L, where's L? Here lo. Okay. Does it make sense? Good. So looks like we need to do a lot more. Okay, hold on, let me see. So this is the north also, right? So the bearing of M from K. Oh, they give you this. So how do you change this? So it's from
M
K north.
From K naught to M is
M. So K naught, where's K naught? K naught is to M is here. So this is 95, right? Okay, that you can quickly find out this already. 180 minus is 90, 85, I think. Yeah. So if this is 85, then you use 360 minus 85 minus 30. That will give you the bearing of this, right?
Yeah.
Yep, good.
Let me find that now.
Yep, please. So I hope you have no problem with bearing anymore.
60 degrees.
Yep. Because I already teach you how do you convert that statement into something that we is easy for our brain to digest. So this one is done. Then KL, where's KL? This one. You see, so you see when you use the cosine rule, when you use the sine rule, because you look at this, it can be cosine rule, it can be sine rule, right? When you use the sine rule, when you use the cosine rule. So what do you think? Sine rule or cosine rule? Sine rule, you must have the sine angle over the opposite side, right? Remember? Over the sine angle again, so opposite side, right?
Yeah.
Right.
Yeah.
So let's say, can you use cosine rule? Can you use sine rule? Try. Sine 58. Opposite is the question mark, right?
KL.
Yeah, KL, which is what you need to find, right?
Yeah.
Is equal to sine angle. Do you have another angle here? No.
So cannot.
So sine rule out.
Cosine rule.
Correct.
So cosine rule.
So I hope you remember cosine rule now. I remember it already.
B square.
B square, where is your B? Yeah, it's B square, but the B refers to which one? The B square actually is the solo one, right? So B square, A square plus C square minus 2AC cosine the angle A, right? So this B square refers to the question mark, right? So it's KL square. So if this is KL, right, then this has to be AC lah. Then this has to be A. Actually, whichever one is okay, as long as you have 6.4 square plus the 7.2 square minus the 6.4. This is times times 7.2 cosine the opposite angle 58. Okay, so how do you decide the B square is the angle you have that point to that?
Okay.
Understand? Because sometimes they can give you this. They give you 8. I might not need to erase this. So if they give you this, how? This is the angle, right? This is the opposite, right? So the 8 has to be here. A square. Equal. This is the A square. Which is what you need to find. Then plus this is your C square. A you don't know, so it's A, so 7.2. Then cosine angle 58. You understand how it works? The one that stand alone is always the one that you have the angle that point to it. Okay? So you have an angle here, right?
Yeah.
So it point to the 8, right? So that's why the 8 square has to be. If I give you this question, you have to form this.
Okay. So that question is.
That question is. They give you the angle 58 here, right?
Yeah.
And it happened to be this is your B.
Okay.
That's why your B is along there. It was here.
Okay.
So I want to give you another situation. You don't always assume that
Yeah. I understand.
Okay, good. So this one, no need. Then of course you solve that quadratically or whatever, I don't know. But so for this one, can you help me out? Oh, this one everything is. You can figure it out using calculator.
Yeah.
So you need to figure out. Okay, this one first.
0.4 square plus.
Oh, you can key everything actually.
Yeah, that's what I was
Yep,
saying.
good.
Negative 2. Is it times?
Times.
6.4. Cosine 64 times sine going to
times cosine 58.
43.96.
Total is 43, okay. Okay, then square root this.
Alright, square root is 6.63.
Remember you have plus minus,
Yep.
KL square,
Mm.
So you only accept the plus one. You reject the negative because it can't be negative, right? So it's positive what?
Positive 6.63.
6.6. Okay, 6.6. Easy. So it's 6.6. Okay, for our convenience. Meter. So this is 6.6 meter, right? Now they want you to find ms. Where's ms? Ms is this part. Right? How do you find ms? So you have
find yeah. So you find the S.
you have this angle.
Yeah.
Can you get this angle out?
But you want to find KM.
No, I want to find ms.
Okay. Why you want to find?
They want to find ms.
Yeah. Why you want to find KSM?
I don't know. I just want to like get the angle out. Maybe it will help. Actually, I also don't know.
Why not you find SKL, right? Then
SKL. Where's SKL? Okay. SKL. Okay, SKL. Okay. Yeah, good.
Then after that,
yeah.
you find out the MKS.
Angle?
Yeah, the angle.
Hold on. I can easily find this, you know. I can easily find this. What's the angle here? 180 minus 58, right?
132. Oh, 180 minus 132 minus 30.
Yeah.
28.
Yeah.
Then sine row.
Okay. You can 30 over this one, right?
Yeah.
Yeah lah. So it's sine 30 over the 6.4. Then you sine 28 over the ms. Yeah. So that's how you get. No, I don't want you to waste time to get. Okay, good. Done. So calculate the area of the triangular guarded KLM. Where's KLM? KLM. The whole thing lah. Okay.
That's a garden.
Yeah. KLM.
Okay.
Oh, we need M. Oh, then we need to find this side also. Because once you find this side, then only you can find the base ma.
Okay, no, then just sine again.
Yep.
Just sine 122 over KM.
122. Yeah. You want to find the question mark, is it?
Yeah.
This one is easy. Okay, good. So to find the area, you just have to get the height, which is this one. The height is pointing to this 30 degree. So this is your opposite. You have your question mark, that is your hypotenuse. So we practiced this last time. I mean just now. So the base is this one. Okay? Okay? Yeah, good. Done. Area done. A tree house of height 3 meter. Calculate the angle of depression. I don't think you have the angle of depression question, right?
No.
Okay, good. So I think it's pretty good. So basically, I think your WA3 will cover A, B, C, D. And I remember you have that question construction, right? Compass and projector. Yeah, we need to go through that.
Oh, forgot about that.
Never mind.
So much things. Cover. You just imagine in the field. Oh my god.
Yeah. Are you thinking about physics?
Yeah.
It's okay. Fail your physics. It's okay.
There it is.
You can fail your physics. You cannot fail my math. Oh, you cannot score B for my math. You can fail your physics. Yeah.
Nah, I don't want to fail my physics.
Okay.
You know, I almost failed my physics last.
It's okay. I'm not involved. I'm not taking care of your physics. I don't feel responsible.
I'm the one taking care of my own physics.
Yes.
Wait. So yeah. Wait.
It's okay. I need the compass and the projector. I'm going to like demo to you how you can do questions like that.
My projector, very nice projector.
Come to here, yeah. Come to here. Bigger space.
You need my pencil or?
Pencil, yes.
Okay. This one.
Yeah, just put everything here. Just demo it. Okay, good. Okay, let's start off with this.
So it's mechanical one.
Yeah, good. Very good. So you have left, right? Okay, good. So, okay, so let's say, let's say let's say I need to draw a quadrilateral, four-sided. So given this. So this is 7 cm given, so let's say it's AB. Okay? So let's say I want to have a ABC angle 30 degree. You must read correctly, So
Yeah, but then.
so what's the length of BC you want?
Like 4 centimeter.
4 centimeter. Okay, good. 4 centimeter is useless. Of course, you can go and measure. This is preferred.
Oh, then you
Okay.
just.
Then you just point here.
Yeah, then you just
Yeah.
close it.
So you just close it. Okay.
Erase the extra.
Yep. So this is your C, right?
Mm.
So let's say you want your AD. Let's say you want your AD to be 5. Same thing. Go to 5. So instead of turning
It's
this, you also turn
12:15.
it. Okay? So anywhere here is 5 cm. Actually, it can be here also. But we are drawing a quadrilateral, so it has to be somewhere here, right? Okay, good. So it really depends what is the angle you want for your this BA something. So let's say 140, yeah. So later we will deal with what perpendicular whatever. Okay, good. So just connect C to D. Okay, so like you see, the rest just erase. Oh, slightly off. But never mind. Don't care too much about this because I want to focus on the perpendicular bisector. What bisector the thing.
Yeah.
Okay, so to draw a perpendicular bisector, right? So let's say I want to find the perpendicular bisector of this AB. Okay, AB cannot. I should have started from the middle actually. So okay, never mind. So let's find the perpendicular bisector of AB. Okay. Remember, when you draw things, must start from center. Otherwise, you have no space here, then you cannot do a lot of things. Okay, this is about space management. So let's say I want to perpendicular bisector of AB. Just do this. By the way, the gap here must be more than half of this line. If it's less than that, cannot.
Oh.
Yeah.
Okay.
Okay. I'm talking about perpendicular bisector. So if you
I thought it must be half of.
must be more than half. Less than half cannot. Never mind. So if you have any doubts that means if whatever I'm teaching you here and then it's not your understanding, then you just absorb mine. Okay. So if this is like this, so you need to make the gap more than half. But of course you cannot more than half and less than itself. Okay?
You
Then,
see the explanation.
then no need for the explanation first. Later we will talk about the explanation, okay? So just follow this one. Good. Then down also another one. Do you know why I need to both sides?
Yeah.
So
then
that you can link up.
Yeah, link up.
Yeah. 2 points to draw a line. 1 point cannot draw a line. 1 point you cannot draw one line. 1 point is many lines. Okay? Only 2 points you know that must be this one. Okay? So similarly, go to A. This one.
Need to elongate.
Yeah. So so I need to. Okay, good. So you got 2 points, and just link it up, and try to make full use of the space. Okay, just extend it out. Okay, so this is your perpendicular bisector. So perpendicular bisector of this AD.
So must put
Yeah.
like a right angle.
Yeah, sure, yes, good. Alright, then let's say I want to get a point that is same distance to DA and same distance to DC. So you know what they are actually asking? Same distance to DA, same distance to DC, actually that is an angle bisector. Yeah, they're asking.
Oh.
Because only when you have an angle bisector means you cut this into half, right? This anywhere here will be same distance to both sides. Okay? If you don't understand last time, I hope after this you understand. If they ask, I want to have a point same distance to one side and the other side, so basically they want the angle bisector of that angle.
Okay.
Does it make sense to you?
Yeah.
So if they want the same distance to this side and this side, then you have to split the angle so that it's the same distance now. Does it make sense? So they are asking for angle bisector indirectly.
Okay.
Okay? So if they want let's say they want the point that is same distance to this, let's say BC to BA, right? That means it's somewhere here, right?
Yeah.
So that means it's an angle bisector again. Okay? So how do you do the angle bisector? This one is it's okay one. No need to like must be this length or that length. So any length will do. So
actually, I think like the small length is more convenient.
yeah, of course, because you don't need to use so much space.
Yeah.
Oh, this one is out already, so small is good.
You mean do it for you?
Yeah, please, yeah. Yeah, done already. Good. Good. What do you do next?
Then after that from here.
Yeah, very good. Good.
Then here or something.
Yeah.
Oh.
Yeah, you can turn the paper if you want. So looks like you have no problem drawing the angle bisector, but you don't know when to draw the angle bisector. Maybe that's the problem.
Actually, in the examples, they all said, "Oh, I want angle bisector."
So
they did not
obvious.
say indirectly. Yeah.
So obvious. Okay. If it's so obvious, then that means it's good to you, lor.
Yeah.
Okay, so just extend this out. Okay. So actually, this point, the intersection point, so let me just tell you, the intersection point is the same distance to this side and this side. At the same time, it's the same distance to point B and point A.
Okay.
Okay. So the question you want to ask me is?
I had no question.
No, you have one question. What's that you ask me on this construction? That's why you talk about it. That's why I asked you to bring.
Oh, okay.
Yeah.
Oh no, I have so much.
Okay. Come back to math. Get your physics out of your mind. Energy is equal to power times time.
Yeah.
Yeah.
Oh no, I forgot to revise that. Thanks for reminding me.
It's okay.
Wait, where is it?
Power is equal to voltage times current.
Oh, I think you found it.
Yeah.
Wait, no.
Because of this synchrony. No, because of this abbreviation VIP. So V times I equals to P. That's how I remember.
V times I? What's I?
Current.
Oh.
VIP.
We haven't done that. Oh, that's electrical. That's
electricity.
That's different.
Yeah.
We never done that yet.
Oh, not yet. Okay.
Is it this one?
Okay, let me see. Yeah, which one? Yeah, this one. Yeah, you ask me what? What you ask me, yeah? Yeah? Who? Part B or what? Or part C? You don't understand which part? Yeah, you see? X is equidistant to point B and you see this is perpendicular bisector. Point B and point A and point B. Now they ask you indirectly. Okay. Then the next one is what? Equidistant from the line AB and AC. Yeah, angle bisector. Right? Okay. AB and BC. So is this angle bisector? Must be in between. So it has to be this angle bisector. You see, they ask you indirectly.
Okay.
Then what other part you don't understand? So during the weekly assemblies, don't gather closer to R than to Q. okay, then I need your.
You mean you're working at?
Yeah, you need working. Someone just quickly get. Where's your ABCD? Oh, this is what?
P, Q, R, S.
Where's your P?
Yeah.
Okay, P, Q,
R,
S. Okay, good. Okay, what they say?
So they say.
Now one part, this part here. So here as a student gather closer to R. Closer to R means here, right? Let me try to go this way. Then Q. Okay, so maybe you get a perpendicular bisector here already. Okay? Then you also have a angle bisector here. RS and QS. So you also have an angle bisector here. Right? Okay, so closer to R. So that means closer to R, that means this entire region. Okay? Then they need to be what? Closer to RS. RS is what region? This region? So this one is gone. Then what they ask you?
Shade the region. So just
done.
shade it.
Yeah. So this is the way they.
Okay.
Yeah.
This is the indirect one.
Yeah. No, this question I find very good.
Yeah.
Okay. So you shade the closer to R, then next you shade use the angle bisector
to find the region, right?
Closer to
RS.
Yeah. And by the way, in fact, closer to RS is more than this one. It's actually all this part. But somehow within the
perpendicular bisector.
Yup, plus within the
angle bisector.
Or this quadrilateral.
Okay.
Alright? So that's the way to do this.
That's an interesting question.
Yeah, very interesting. I like it. Otherwise it's boring.
Boring.
Yeah, just like what? Sub in power, sub in T, then you get energy, so boring. Alright. Okay, back to this.
Do you still remember kinetic energy?
Yes. Half mv square. Yeah, that's so boring.
Do you know what's power?
Power? Power is
Is work
VI.
over time.
Oh, okay. So energy.
Power is watts.
Power is what? Okay, good.
Yeah.
Okay, actually power can be VI, you know. That one is another one.
Yeah, that one I still haven't learned that. So yeah.
Okay, good. So, did you ask me other question?
I don't know.
You don't know. Never mind. Let's go back to
There's so many questions. I even asked my teacher questions.
Oh, congruence.
Oh yeah. Oh my god, there's so many questions. You need any of these like protractor?
Oh, I have plenty. Projector I don't need. I even have a very big projector.
Oh.
Later I can show you. Bigger than usual. Okay, let's look at this. What? Name a quadrilateral with 4 equal sides and unequal diagonal. So what is that?
Name a quadrilateral. Oh, this is the one I don't know. That's why I highlight.
4 equal side. So it's diamond. So unequal diagonal is so the diamond don't work. That means the rhombus don't work.
What do you mean don't work?
Don't work. I mean don't fit this. Don't fit this description or requirement. So about the square, same diagonal, right? 4 equal side. Parallelogram.
Is it E, F, D, then some unknown one?
Trapezium? Yay! Trapezium! 4 equal side.
I didn't know that. I didn't know trapezium can have 4 equal sides.
Can they have equal side? 4 equal side?
No,
cannot.
Yeah, see, cannot.
So how? Okay lah, I never asked you to score 100 lah, so 1 mark give away lah. Okay, so let me go and figure this out on my own. So far cannot figure out yet. Okay, what else? This you know the rest. That means how do you find the interior angle of a hexagon? Use the formula, right? What is the sum of interior angle for polygon? Interior angle. What's the formula? Is side minus 2 times 180.
Yeah.
Yep. Actually, there is another one. Angle times one of them. One of the interior.
Nah, I don't want to know. I just want to stick to side minus 2 times 180.
Actually, there is one more.
Okay.
You need to know.
Okay.
Sum of interior angle, you know. But what about sum of exterior angle?
I forgot.
360. Do you know why I give you this question? Because this one, they can somehow test you in this manner. Okay? Sum of exterior angle is always 360. Okay, why you need to know this? Because sometimes they will give you the one of the interior angle. Then you need to find a number of side. But never mind, you really need to remember all of this. Okay? Okay, good. So explain why triangle are congruent. Why they are congruent, you know?
Nah, I don't know.
So you need to get the two triangle out first. Draw it out. So F A B. So CBA is C B on top A. So you need to match. Do you know why I want to extract them out? Because if I don't extract them out, I don't extract the two of them out, right? You're actually looking at this. It's very hard to tell. It's very hard to tell. You understand me or not? It's very hard to tell. So it's better you get them out. Okay? So one thing I think you can you can say is the side is the same. Can you see both A, B, A, B? So you have the side equal to same. So A, B equals to B, A lah. So this is common lah. So you have the side already. So you think of what else can you use? Left side, S, A, S, A, S. So which one you want to use? Can you prove another two sides? I think so. 这个 BC and FA. So BC and FA, they are the same. Why? Because it's a hexagon. So you can use SAS already. Or SSS. Okay? So what's this? So it's AFE is. So you see, once I extract it out, it's very easy for me to match, you know. Can you tell or not? So remember, when you do similarity or congruence, always extract the two triangle out. You can see very clearly and match point by point, angle by angle. Are you clear or not? So AF is BC. So this is hexagon now. So hexagon. Right? The reason is hexagon. Hexagon all sides are the same. Regular. Regular all sides are the same. Not regular, no. Then you just need to find one angle is the same. So which one? Can you prove that this angle is equal to this angle?
FAB equal to CBA.
Can you prove? Or you can prove other angles, like this one.
Oh, what about ABF and BAC?
Angle? Are you talking about angle?
Yeah.
Again, FAB is equal to this one, right?
Yeah.
Yes, because they are both 120. This one, right? 120, right? Right?
I never really like prove congruence and similarity in hexagon.
Never mind. What I'm telling you is you don't. This is the kind of question you will get. They can give you a polygon, like it can be hexagon, it can be pentagon or whatever. Then they somehow mess up the hexagon or mess up whatever. Then you understand me or not? Okay. So basically, don't expect like they really like make it so easy for you. No. So this is 120 because you found it as interior angle, right? FAB is equal to CBA. Okay. By the way, is you match FAB with CBA. You don't go and write ABC. Because you start with this. You start with FAB, then you need to start with B. So that's the reason why I asked you to extract the two triangle out. match the point, match the angle. Okay, so you will get this is what 120, right? Or you can write it equal to 120. Then interior angle. Okay. Then this is your A lah. So you just rearrange them. So probably you want to bring this statement up, down. So you have the SAS. Then there is done congruent. So congruent means you use triangle FAB is congruent, 3 lines, CBA. Yeah. So you write down SAS. That's how you prove. Understand? Actually, the most important thing I want you to learn is extract the two triangle out. Because once you extract the two triangle, it's easier to see.
Okay.
If you don't extract it out, it's very hard to see. Okay? Then find the obtuse angle FXC, where FXC, which is this one. Okay?
Is it like vertically opposite?
To this one?
Yeah.
And then? So in a way you can tell that this is an isosceles. Or in a way you can also tell this is an isosceles. So you can find this small angle already. 120, then that means 180 minus is 20. So this is also 20, right? So if this is 20, this is also 20 because isosceles. So this is 100, 140, yeah. Okay?
Then? So then FXC is 140.
Yep, yes. Because the opposite.
Yeah.
Then of course, given that the diagonal AD, okay, this diagonal, bisect the angle F. Okay, bisect, so means this is equal to this.
Like angle bisect.
Yep. So determine if the parallel, if FE, where's FE? FE is this. Parallel to your AD. So you somehow just need to find that the angle are the same. You understand me now? So this is another way to prove. So to prove, that means you need, okay, parallel means this one add up to 180, or this one add up to 180, okay, or this is equal to this. So basically you just make use of whether you can prove that
corresponding
coordinate or integral. If you can prove, that means they are parallel. You cannot prove, then cannot. So that means you need to find out all the angles. Okay? So I really think that this kind of question is expected, not like your usual one. Okay? Okay, we can go one more question for similarity. So today we focus more on E-math.
Yeah.
But that doesn't mean it's easy, okay?
But
yeah.
But is there anything in E-math you need to see? Or
You have any question to ask me? Or
I think you can check E-math. Actually, E-math, I think I finished all the questions. I attempted all the questions.
Yeah, okay, then. Okay. Anything that... the shoelace.
Yeah, I remember. Okay, I was revising my physics. So
never mind, next time you always wear shoes with shoelace. Then you will remember shoelace. Next time when you tie your shoelace, think of shoelace method.
Okay.
So don't wear slippers already, okay?
But during exam, I will wear my shoe. So don't worry.
Okay. So next time maybe you say, how to do this question? I have a shoelace. Okay, no. Okay, good. Similarity. So yes, to get similarity, once again they ask show that it's similar. So get the two triangle out first. ATP. Okay, ATP. A. T. P. So this one.
Okay.
So get it out. Wait, this is tangent to the radius, right? So tangent to the radius, what it means? 90 degree. Right?
Oh.
Okay? Then BT is there.
Man, I should go also revise my equation of circle. I never revised that yet.
Ooh, you need to do that. But anyway, we have done some heavy lifting questions already. Yeah. Then okay, good, done. So it's 90. Okay, so for this is angle, right? So you already found this two.
Actually, my teacher say
right?
Yeah.
And then common, can you see common?
Common.
Done. Proof. Okay, so angle T is equal to angle T common. Then this angle TPA is equal to angle T.
Wait, it's not given, right? is.
No, I'm not using given. TQ, what is that? TQB is equal to 90 degree. I use tangent to radius. Yes.
That's the
Reason.
I never seen that reason before.
No, tangent to radius is always 90 degree. We talked about it the other time.
Yeah, but
The equation of circle.
oh.
Okay?
Yeah.
So therefore you have AA done. So triangle ATP is similar to triangle BTQ. Okay? Show that T is 2. T is 2. So that T, do you have TE? No. So you need to get it back to this. T is 2. Okay? GE is 16. This one is 16. Okay? Then this is 12. Right? So that means this one is 4. This is 12, which is the diameter. So this one is what? 6. Then you fill it up here. 6. So this is the diameter. Okay?
Yeah, so it's 2.
So this is 4. So it's 2. So this is 2. This is 2. You see, it's easy to match already if you extract them out. That's why I emphasize this so many times to my students. I say, get it out. So this is, because this is your point E, right? So this is 2. Right? So it is your, let's call it X. What is your BT? This is also X. Then BT is this. So this is 6. This is 4. So it's 10. Okay, good. I can figure it out. So it's X plus 2 over X plus 10 is equal to 2 over 6. Can you read that?
Yeah.
Okay, good.
Ratio.
So ratio. So it's, yeah. So I just leave it to you.
Okay, cross multiply.
Yeah. Okay, so good. Done. 2. Find the ratio of the area. Oh, yes. So you can use, if the length ratio is 1 over 3, right, for this 2, what is the area ratio?
Square lah.
Yeah, square both sides. Yeah. I mean square up and down.
Yeah.
So it's 1 over 9. Okay? Good. So in a way you can make use of that. So if this is 1 unit, then the whole thing is 9 unit, right? So I mean if this is 1 unit, this is 9 unit area. So this is 1, the whole thing is 9, so basically this is 8 lah. Right?
Yeah.
So therefore the ratio done. 1 to 8. Okay? Then calculate the area of shaded region. Don't tell me shoelace. Don't work here. When can you use shoelace?
Coordinate.
Yeah, you can get the coordinate. Okay? Then the area of the shaded region, which is this, right? Okay, then you find this sector.
Oh my god.
Find the sector. No, it's easy.
It reminds me of PSLE.
Yeah, kind of like that, but much simpler here. So you can get, this is 1, the whole thing, this is 1 unit. Then you can figure out this part also.
Huh?
Then you can figure,
Can you?
Can you get the angle out? Or you cannot?
How do you find the area of that section?
Oh, you can find, okay. In fact, you can find this, okay, so, actually the angle is the same. Right? So if the angle is the same, then, if the length is different, right? So you find out this is, I remember this is 2. Then this is what? 6. Okay? So in a way, right, this sector, they are also similar. So when they are similar, length ratio, and then of course you use the area ratio. If this is, so the whole thing is 1, okay? Then the whole thing is 8. So what I'm trying to say is, let's say if this is 0.5, this sector, this will be 1.5.
Okay.
Right? So this is 0.5, and this small thing is 0.5, that will give you 1. So this is also 0.5. No, this is not 0.5.
That's tricky.
Okay, this one take a bit of time for, but it's okay. So go back and think about it. Because I have one question I want to, oh no, there are one thing I want to remind you of, which is the property of circle. Remember the other time we have a circle,
Yep, other time.
and then we have 2 points on the circumference. I just want to tell you there is a better way to do this. So let's say this is your 1 and 4, this is your 7 and 4, and we are asked to find the center, right? I make use of that formula, right? Can you still remember formula? Equation of circle? X minus center x coordinate
then y
plus y
minus
minus the center y coordinate square r square, right? Okay, so in a way, right, actually you I think your school like to use a and b lah. Yeah, it's okay, so we just use a and b lah. Okay, so this is the formula. So I used the formula to get this a and b last time, if you remember.
Yeah.
Okay, but actually there is a better way. Can you see that they are both 4, meaning this line is a horizontally straight line. So if this is a horizontal straight line, right, you just use midpoint theorem, then you can get the a already.
Oh.
Okay, I just want you to note about this. Okay, just use midpoint theorem. 1 plus 7, sorry, divided by 2, so it's 4. Yeah, so a equals to 4. So you can quickly get the coordinate of x, the x coordinate.
Yeah.
Yeah, then it's much faster already.
Then to find the y coordinate.
Find the y coordinate is very easy because you just need to know that this and this is the same. Then you equate. So because this is the radius this is the radius, right? So how do you get the radius? So you have x, which is 1 here. So 1 minus 4 square plus y, which is 4, minus the b, which you don't know, square, this is the left hand side, equal to, make use of this part, 7 minus the 4 square plus 4 minus the b. Okay, then you solve it. Okay, one equation, one unknown, you can solve for the b to get the y coordinate.
Okay.
Okay, good. So go back and revise the circle or equation of circle. Alright, yep, so yes. Okay, so hopefully today we had a very good revision on e-math. And I don't think you, okay, so you just go back and okay, maybe I will just send you some questions on what's that, the Tokaso one, the sine rule and the cosine rule, so to test you further, and of course the similarity and the congruence. Okay, so basically I just give you another set of e-math.
Actually, A-Max I already have a lot of questions.
Yeah, no problem. So A-math I will stop giving you. Okay, unless you have questions, and then of course the construction one also.
Okay.
Okay, so yes.